So you can download QGIS software from this link. Also, you can also download directly by typing the QGIS. QGIS. The new version is I think 1 GB memory. So that's a download. Just keep it and go to download. Then long-term version of Windows or latest version. So you can choose any one of these for downloading. So it is free of cost. There is no any fees for this. Then we have to go to the QGIS. So suppose I want satellite image as a base map. अगर कुछ बेस मैप और सैटेलाइट इमेज हमारे पास नहीं है तो जो गूगल का बेस मैप है इट इज़ इंटीग्रेटेड विथ QGIS, तो इसको हम एज ए बेस मैप यूज़ कर सकते हैं। उसके लिए एक ऑप्शन है वेब मेटा सर्च, इसमें होना चाहिए। मेरा एक प्रीवियस वर्जन है इसलिए नहीं है, तो कुछ प्रॉब्लम नहीं। जस्ट गो टू द प्लगइन. So plugin is generally used. A lot of small tools and softwares are there for any type of application analysis, like urban sprawl. There are 2-3 models are there. I will show you in the next slide. So this is a plugin. Okay. Just search Google. So this is already actually I have just installed. It is just any type of suppose shoreline. So this is also a plugin, that is QGIS shoreline change analysis tool. A lot of tools are there. You can just search and download and just install. So the plugin. Load base map. This is the E3 base map. Then go to the world imagery and load.
What was the name of the plugin for base map?
Plugin is base map. Just go to the plugin, then manage. Just a second. This is base maps. BASE base map.
Right. And OpenStreetMaps can also be imported in QGIS also, right?
Open space?
OpenStreetMaps, OSM.
Yes.
For that, it's a different thing.
So there is a need of any reference system is there. So if reference is there, there is no problem with this. Just a second. Install zip file. Okay, just this is the base map. So it is look like the Google Google image. So it is very high resolution. So 0.5 to 0.6. This is very high resolution data. So it is used as a base map for our any type of analysis, but we cannot we cannot analyze all this satellite image, but it is only for view purpose only you can use, or you can also use as a latitude and core mapping using this base map, but you cannot download it. Okay, then suppose I want to georeference a toposit. I have some toposit map is there. So this is the Survey of India toposit. So this toposit is from Bhubaneswar, and this is the Mahanadi River, and this is the forest area near the Bhubaneswar, that is Dampara Reserve Forest, and we have to georeference these toposits. So there are two type of georeferences there. One is georeference using the latitude longitude और इमेज टू इमेज. अगर हमें कुछ लैटिट्यूड लॉन्गिट्यूड इंफॉर्मेशन है फोर कॉर्नर का, देन वी कैन जियो रेफरेंस इट. अगर नहीं है, सपोज वन इमेज इज देयर, so it is not georeference, then we have to find the reference satellite image of the same area, then we have to find the same points and same locations, then with the help of these locations we can georeference. So that is called image to image georeference, and and this type of georeference is coordinate to image georeference. So we generally use latitude longitude coordinates. So this is the 1:50,000 scale toposit. So each total boundary is 15 minute into 15 minute. So you just see the 85-30 minute in the lower section. This is the 85-30, and the right side is 85-45. So this is the 15 minute difference is there. So in the lower side also 15 minute into 15 minute. So generally in the geographic coordinate system we use the degree minute second in the form of latitude longitudes, and in the 2D form we use the decimal degree, 220 point something or 80 point something in the XY coordinates, and it is in the 3D form of the coordinate. So 1 degree is 60 minutes. So we have to georeference it because it is not georeference. First we have to check either it is georeference or not. Just add the data. From toposit sample, then add. So this toposit is from this area, so it is not fall in the proper locations. So just check. So it is fall in the outside of the world. So it is not a reference, and the coordinates are very different. So just close this. So in the ESPG, there is a in the lower right corner, that is EPSG 3857. There is a number. So this is the coordinate system. So what is the coordinate system of EPSG? We also know that there is a WGS. हमको पता है WGS is one of the coordinate system. So it is like that. I just show you one thing. So EPSG is generally European Petroleum Survey Group. The full form is EPSG, and so different coordinates like 4326 is a very standard coordinate we are using for the Indian. There is the coordinate reference system, and it is like the geodetic coordinates, so WGS, and the important thing is that the QGIS founder is the Gary Sherman, is an American software developer and geologist. So this software is generally widely used in the European countries because it's an open source software, and a lot of updation is continuously growing. So previously there is no such other functions are there. So now if you are download this QGIS, a lot of programming and some lot of links are there. You can download a lot of uh, you can link with the Python, and you can download some satellite image with some of the links are there, and different tool and different models are also included, and you can download from the Google sites different plugin, then install it, then use it for different purpose. So it is very much user friendly, and that's why it is nowadays very widely used in different sectors. So this is the global standard coordinates reference system, EPSG, and this is 4362. So generally, we are using 4362. But if you have, if you have, have knowledge about the locations, then you can use the UTM zone of 42 north. That means 32642. 43 north. That is 32643. So 326 is common for all this in India. So you know that the Indian longitude is stretched from 68 degree to 97. So this is the 68 to 97 from Gujarat to then Nagaland. Then latitude also from lower 8 degree per minute to 37 degree north latitude. This is the extent of the India. So if you are from central India, then you can use ESBC 32643. But you don't have, if you don't know about all these things, then just use WGS 4326. It is common for all. So these are the UTM coordinate of the whole the world. So in India, that is 42 to 46. This is our zone. Within zone, we have to work. We have to give all the coordinate systems. So just change zone to layer. Just change is to 43226. That is WGS World Geodetic System 84. So it is started in 1984. That's why it is called as 84. Okay, then apply. Then okay. Then go to the layer. Then georeferencer tool is there. For georeferencing, we have a tool in layer file, that is georeferencer. Then there is a tool that is open raster. Just click open raster. Then toposheet sample we have to add. So this is the, so we have already given the points. So we have to geo-rectify using this coordinate system. So generally in the, it is in the 3D form, like in degree, minute, second. So if it is in 2D form, then longitude is the x coordinate and latitude is the y coordinate, because this is the longitude. So the progression is like this. So towards it, or it is increasing towards the east, decreasing towards the west. It is the longitude. Then latitude is up down, so north to south. That's why it is y direction. So just click on the middle point. Then the x is east, that is 85. After input of 85, then just give the space for minute. So 85, 30 degree, 30 minutes. Then y, that is 20 space 30. Okay. Then change the projection 4326. So there's a red dot is there, then it is completed. First point is completed, then go to the right point. '85, 45, then 20 space 30. I think some error is found. Okay, the 2 points are completed. In 85, 85, 20, 15. So X is something that is completed. Then the last point, 85, 30, 20, 15. Okay, the points are completed. Then the residual error is 1.5 or 1.2. So it is near to the 1, so it is not very wrongly interpret of this point. So the 4 points are completed. Then go to the setting, transformation setting. So this is the linear transformations. Target is 4326. Output file, go to the, just save it. It's a reference deposit. Referenced, geo-referenced. Okay, so it is in TIFF file. Save it. Then okay. Then click on start georeferencing. So after that, the georeferencing started. So it is now georeferenced. Just close this window and just zoom to layer. So now it is in the right place. So we have seen that previously there is the non-georeference opposite is not placed in the right place. So just click on the properties, then transparency, apply. So it is exactly placed in the right place. The back side is the satellite image. This is the Survey of India toposit, so it is very accurately measuring all these features. So yes, it is a very old toposit, like it is I think from 2010 or 2012 is there. That's why some river course is changes in some areas, and some urban area also a lot of changes is happening. So these are some dams, the reservoirs are there. So we can now we can digitize a lot of things in the point or line or polygon using this toposit, because lot of informations are there, like road network. Suppose there is a reserve forest is there, so this is the accurate reserve forest boundary. This green boundary with black dotted areas. Just zero, just transparency. And this is the water bodies. This is the Onsupa Lake. Now it is declared as a Ramsar site recently. So this is our georeference uh, toposit image. So how to draw polygons? And after georeferencing, we have to work in a point line polygon. So there is a layer, create layer, then new shape file. We have to create a new shape file for creating a polygon. The name is, suppose I want to extract some forest area. That's why my name is my layer name is forest. The encoding is by default is there. So geometry type. So point, multi-point, line or polygon. So for forest area it is polygon. The field. Suppose I want to measure area 1. Then area will be in decimal. That's why I just add to field list. Then description. थोड़ा सा different complex है RGS से. RGS is very easy for this operations. Then for description it is text file. So I add to field list. So now okay. Okay. But previously the forest is there. Forest BNT boundary. Okay, then forest boundary of the polygon layer is created. Then just click and click the outline is green, so that we can easily identify what is the forest area. Then just right click and click on toggle editing. Then this tool is created, add polygon. Then we can add polygon. Suppose this is my forest area. Just create polygon. So ID is 1, it is by default created. Then area is not known to me. Then description is suppose RF. Okay, so it is a RF. So create some one polygon. So likewise, you can create a lot of polygons there, and as per our use, we can use this polygon. Then go to the attribute. That is the open attribute table is there. So if we want to know what is the area of that in square meter or any square kilometer, then change this into area, then statistics, go to the statistic, then just type area, then OK. Just click on OK. It is not still found the area. Just click on the update all. Then the square meter area will be in the square meter. So if you want to change the area into square kilometer, then just divide 10 lakh, then it is converted to square kilometer, 1.2 square kilometer. Likewise, you can
Sir, where did you divide it? What did you click in order to
actually
divide
for
10?
square meter to square kilometer, which I just divide one is to sorry into 10 lakhs.
So which you went to expression builder in order to
Yes,
change
yes,
the.
expression builder is there. Likewise, you can also change into hectare also. So one square kilometer is 100 hectare, I think. So for this also we can use, but in RGS it is different, and you can directly calculate. So this is likewise you can download, you can create point, line, polygon. So I just already I will provide all this material in the, just provided all the functions and all the steps in the PDF. So I will provide soon. Then, so point, line, polygon is you can create all this. Then area is calculated. Then band compositions. So FCC bands, how to create within with the use of single bands. So we have used in the R programming and ArcGIS. So in QGIS, how to create this band combinations. So now we will see this band combination. So for band combination, I have to add which type of data? This band 3, 4, 5, 6, 7. These are the bands. So suppose I want to add 3, 4, 5. So rest are not required for false color composite, but you can change as per the requirement. So I just want to add this 3, band 3, 4, 5 from Landsat 8 satellite image. So I have a Landsat 8 satellite image. This is the Landsat 8. This is 3, 4, 5. This is the same area, which is opposite of the same area of the Bhubaneswar. So these are the three bands. Just arrange it from blue, green, red. So one band 3 into upper side. 3, 4, 5. So 3 is very dark. Then 4, then 5. This is the infrared band. That's why all the water bodies are clearly visible. But in blue band, you cannot see all these water body clearly. This is the difference of the reflectance value in the different bands. So just we have to add all these three to create a color image. So to go to the raster, there is a raster tool, then miscellaneous, then create a wheel virtual raster. Just click on it, then click. These are the band 3, 4, 5. Just click on 3, 4, 5. and okay, the input selected. Just click on place each input file into a separate band. After that, we can create a different color, then run it. I think I have given the output name. It's not. Okay, this is the virtual color image. Then go to the properties. This is not the false color, so it's randomly change the bands. So in this, there is a red, green, and blue band. So in the blue band, we have to change into band 1. Then green, it is band 2, and red, it is band 3. Then apply, then it is changed into false color image. You can check with our base image. This is the base satellite image. Then this is the false color image. This is the water body clearly visible. So this is, I think, 30-meter resolution means we can measure it, the pixel. Yes, 30 meter. That's why the resolution is not very clear as compared to the world view image.
So how did you find 30 meters? Again, can you show?
Okay, I'll show you. So 30 meter means each pixel's dimensions is the unique pixels. So just click on the measure tool, then it is seen in these areas. If I measure, then it calculates. So each boundary is 30 meter. Then it is 30 meter.
Where was the measure tool?
Measure is in the upper area. It is in the measure
Okay,
tool.
that one. Okay, okay.
Measure line area, and you can also measure area using the tool square meter. 30 meters means 900 square meters is there.
Thank
Equivalent to 900. Okay, you can measure. So any satellite data, if you don't know about the resolution, then just measure, then you can know this is the resolution of satellite image. Then we completed this georeferencing and then color composite. Then we just proceed to vegetation mapping, that is NDVI calculation. So for NDVI calculation, there is a formula like infrared minus red divided by infrared plus red. Likewise, a lot of indices are there for built-up index or urban development feature showing. The NDBI, that is normal differential vegetation build-up index is there. Water index is all there. So a lot of formula are there. So we just give the band information, then it calculate the different indices. So generally in NDVI, that is ranging from -1 to 1. So which is close to 1, that is called vegetations, and what is lowest part is the water bodies, that is minus near to the -1, and some agriculture areas maybe 0.1 to 0.2, but vegetation is 0.3 to 0.7 and 0.8. It is calculated. So just see, uh, just we have to choose only two bands, that is infrared, which is now in our uh, software, that is 5 and 4. So we need only 5 and 4. So just to go to the raster calculator. This is the raster calculator. In the raster tool, then we have to give this formula like red minus infrared minus red. So we have to create a bracket because the calculation is for this band. So band 5, there is our band 5, infrared, then minus red, band 4, so bracket close, then divide by bracket start infrared plus red, that is bracket close. This is our formula. So this file is infrared file. We can change the name as infrared, but now it takes time. So infrared minus red divided by infrared plus red. So just save it in output NDVI. NDVI L, then set 8. Okay, then save. Then there is the 4326. Everything is okay. Then just apply it. 4326. No transform boundary box to targets here is okay. Okay, just try another time. I minus 2. Just copy it. Okay, then NDVI is created. So this is the NDVI value. We just create the color RAM. Then after that we can use this. So then go to the right click on properties of this NDVI image properties. Then click on the render type, single band pseudo color. Go to the single band pseudo color. Then you can change these colors, color RAM. Then apply. The top value is highest vegetation value is 0.49. Just give totally green area. So this is the NDVI classifications. So the water value is very low. That's why this is the ramp of the value is ranging from minus 0.218 to 0.493. So highest value is the vegetation area, lowest value is maybe the water bodies and other areas are there. And agriculture is between 0.1 to 0.23. So we just see the value, click on the identify features I and just zoom it and then click in the water bodies. So the value is minus 0.07. So if you click in the vegetation area, it is 0.43. So and if you click in the agriculture area, it is 0.09. So this is the value of NDVI for different features. So NDVI is generally calculated for the vegetations. So if there is a vegetation of a lot of greenery, then what is the value? And if it is a degraded forest areas, then the value is decreases. So in the same forest area, different values is we can see there is 0.30 and for dense areas that is 0.41. So that's why we can calculate all these areas of some dense areas and open area and some degraded areas based on the values and NDVI calculations. And change detection of NDVI also possible. Likewise, you can change. So in your practical also, in your exam, some of the question will be arise. So calculate the NDVI, calculate. So just create, and we have a three band. Just create a color composite, or some draw some polygon and with show some area. So this type of practicals will be there. Just practice it. I just second. Just So this is total handout is there in the soft form. So I just give you all these functions, how to create a different layer. All these are given totally briefly. So there's no confusion will be there. So I will give you this file, and you can just practice all these practicals with the installation of the QGIS. So now the QGIS is far better from earlier. You can any type of work you can do with QGIS. So previously RGS is dominating in all the features are there. So now gradually the QGIS update a lot of features and a lot of things are there. So different type of analysis are possible with the help of QGIS. So it is not low version software. It can do anything. Okay. So this is it, and some basic practical and some how to download the softwares and all these things are given. And you can change this different bands by combination of different bands 343 423. So if you give different band combination, then the image color will be look like this. And these are some plugins are there. So for urban sprawl, there is Mollusk and GeoSound, QGIS Wave. For climate study, there is Saga, Grass, Climate Data Operator, Time Manager. For Soul Line, there is DSS tool is there, Profile tool, SCP, Agriculture for last tool, Agroclimate tool, land degradation, that is Saga, DSMW, Soil DB, Open Land Map. So lot of plugins are there. So don't download all these things. So as per your requirement, just download specific plugins for your work. So it is very much useful. You can use it for in your research work or any project work. It is possible very easily. Okay. Today this for it, और कुछ डाउट है तो पूछिए.
Tomorrow we have class, and at what time?
नहीं अभी तो टुमारो है. टुडे इज द लास्ट क्लास. That's why I just demonstrate this practical session. There is no
It
class.
was very, it was very useful. I think all the
Okay.
sessions were extremely, your all the sessions were extremely informative and useful. So I wanted to thank you for all the knowledge.
Okay. 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 Thank you. And if you need any help for research or any type of work, then you can contact me in this mail ID which is given. And for any research purpose also, if any problem is going on, then you can also contact. No problem. So from the IGNU side, I have just tried the best of my uh, experience, because I have also official work. So after that, I just join within 5 to 10 minutes. That's why the sometimes some slides are not prepared uh, as by my requirement. ओके देन आओ कुछ और कुछ डाउट है तो और कुछ रिलेटेड टू जीआईएस और एनी
Uh,
एक्सपेंस.
Sir,
Sir,
you have shared a
one
message
point.
in the chat box. Can you please share it again?
Which
Actually,
one?
it's not showing.
Which one?
There's a link, some link in this message.
Link. Okay. Now it is showing.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Okay. Just copy it and then use it.
Sir, a few days back, I had a small request that that drone workshop that you attended. It was very interesting. You had
Yes. Yes.
shown
Yes.
in your
In
screen.
IIT
So,
Bhubaneswar.
yeah, is it possible for you to share some insight? How did you actually get the drone images? You showed one drone software. The entire field was getting mapped in, like, there were two kinds of green and blue lines. And then I'm very interested in that technology also.
Okay. So I just give you some basic, because I have no uh, that type of software is there. So first we have to plan a flight timing. So from which area we have to take our flight. So maximum in the drone. So we are using small drones. So it can survey maximum 30 to 15 hectare area at a time. So it takes maximum 30 minutes. So their range is 30 to 35 minutes. Within this time, they can fly. So their range is some higher version is 1 hour maximum. So we have to plan the flight from 20 to maximum 20 to 25 minute of flight, and just suppose I have a, I have a I have a just area. I want to fly a flight in this area. So I just create a polygon. Suppose this is my area. I have to fly it in this area. So we have to check it in hectare. This hectare is not there. Feet, sorry, square kilometer hectare. There is a 20 hectares, so it is not possible for surveying this area. This is suppose 15 hectare. I just save it. So after saving it, and just save it as a KML file, flight one. So this is our KML file. So I have just demonstration PDF is there. Drone. So this is called geofencing. It is not this area. Drone. So this is my area. So it is also same area making. So this is at 11.6 hectare. Then it is saved as a AY or KML file. Then flight planning using drone link, there is a software is there. So we have to put this KML file in this software. Then it creates some flight plan. So this is the how this flight will be there, how to movement of the flight. So this is the automatically it create the plan, and also it give the timing. How much time is requirement? How much time is required for this flight plan? So just see, just completing all this, then we have to create some velocity. How is the speed of our flight? Then height. So if there is a greater height, then the view is very good. So this is the drone link editing window. This is the drone link software is there. So it is not available to me. I think it is 40 to 50,000 cost is there. So these are the KML file. Just click on this, then some KML is in automatically imported to these areas. So in the map, just import. Then this is the file. So this is created the automatically flight direction. This is the point from which we can monitor the drone. So this is the AI speed limit is 16 kilometer. So after that, all this setup. So this is the altitude 86 meter. Then everything is okay. So side overlap. Huh? One thing is so from drone image, yeah, like the aerial photograph, there is it must be the overlapping, because if there is no overlap, we cannot stitch all these images. So all this photograph it can take. So these are automatically geo-rectified. So the side overlap will be minimum 60%. So from one side to one side is 60, or in the width sides, that is also 60. So in the 60 overlapping, they take the photograph. So
So the overlapping is basically this and another 11 hectare area side by side, or is it overlapping within this? What is the I
overlaying,
mean?
suppose there are two tiles are there. Suppose the drone is taking photograph from one click, then after 2 seconds, then again click
Okay,
one
okay, got
photograph.
it, got it, got it. Yeah.
And these photographs are 60 to 70% overlaps. So because
So every yeah,
the two thing
please,
is
please.
there. So if there is a overlap, the two thing is we can easily identify these locations and also georeference. Second thing is if there is a overlapping, then we can also create the DEM data, digital elevations, due to the different stereoscopic views. So in drone image, suppose there is a 3 meter, this drone has a 3 centimeter resolution, spatial resolution. But in DEM data, it is 5 to 6 centimeter DEM resolution. So it's very good DEM resolution. So it is not found in any satellite 6 to 7 digital elevation resolutions. So after that, we can done all this processing. Then we go to the field, then open the drone, then automatically it fly to a particular area, and we cannot do anything. Only just open it, then just click on the KML file which is created, then it automatically fly to these areas and automatically click in different points the photographs. So we can just adjust at the time of operation in the system, but after completing this, in when going to the field, there is no monitoring is control in your hand, so it automatically create these areas. So these are the some flight plan. So these are the points. So in these points, it can take photograph. So you just think that in small these areas, there are 223 photographs are taken. So this is the uh, area of different photographs are there. So this is the thing. So this is not a very complex thing, but there's a photogrammetric software is also there. So all these are just we just take all this photograph, then import into the software, then it create and build all the 3D, then create the mosaic image, automatically create all these things. For this, we have to purchase some software. Otherwise, we have to manually georeference all these images. A lot of things are there. Then photogrammetric checking. A lot of things are there. So for this, there is some software are there. So automatically, it create for final use of this. So after completing this mosaicing of small image, then it can be analysis with the help of QGIS or ArcGIS for any type of. So it is after creating in the drone software, then it is useful for in a different sector in the IMG format or TIFF format. So
Thank
lot
you, sir.
of
It was very interesting.
Okay. So it is no. So nowadays you can create, you can purchase the survey-based drone from 60-70,000 to a good drone is available in 1,30,000. It is in online also. So 1,30,000 you can purchase nowadays, but a lot of spectral band, different spectral, multispectral sensors are there in a drone, and also hyperspectral drones are also available. So hyperspectral drones are, I think, 60 lakhs to 1 crore. One drone is the price of one drone. But in multispectral, you can purchase within 5 to 6 lakhs. So now it is uh, costly, but nowadays, after some times, drone will be very easily available like the smartphone because it is very much usual things and you can use for different purpose.
And sir, are there any like regulations? Because there can be, security issues are also there, and maybe drone might be also interfering with other things like other flights, maybe during near the airports and all. Are there any government regulations regarding to operation of
Yes,
drones by civilians?
there are no flying zones are there for specific temple or archaeological sites and some airports and other government organizations buildings. But we don't need such type of survey in these areas. But we are working for rural areas for forest mapping or for any water bodies estimations or urban areas. So the flight height is maximum 2 to 300 meters. So it is not as much as risky. So we can use it, but for particular purpose, if there is a mass scale surveying is there, so we need some permission from different department. Uh, Personal use for particular area in the rural area or any uh, small areas, you can use as a. So generally, we cannot fly drone without use of this for purchasing this in 1,50,000 just for practicing these things. It is not like that. For particular purpose, we can purchase it. So that's why it is available in different department. Okay.
And sir, all the drones have this drone software like embedded, or is it like Drone Link is a specific company software, or it can be installed in any hardware? I mean the drone,
No,
because
actually, yes, I know. Drone, if you purchase drone, then some inbuilt softwares are there for processing. But for processing and flight planning, there is a software within their purchase. But for photogrammetric analysis, 3D mapping, some of the softwares are there that cost from 40,000, 30,000. And if available free of cost, I don't know, but may be possible. But still, I did not found any software. But maybe in near future, it may be available in free of cost, because if it is spread like this, then it is possible, like the QGIS.
Thank you very much. It was
Thank
really
you.
enlightening.
Thank you. Okay, then today, अच्छा next exam कब है? Exam
Exam is
Sir,
for
maybe
the
in
second
December.
December.
Yes, sir.
Okay, so
17th, 19th, and I think 22nd December for the second semester CGPA.
okay. So
All the
if
other theory, practical might be in January.
okay, okay, just practice it all these things, and I will provide all this material. Or if any in future any other practical related topic is there, then I will just give you link. So if you are interested, then we can discuss different practical and some a new model based analysis. Okay, if time
Sir,
permit.
I have a question.
Okay.
Sir, like last semester, we have separate practical classes. So, if this will happen same in this semester, or the practical you taught us today is enough for the second sem?
No, no, actually, it is my, it is from my perspective. I just just to schedule this practical, but it is not in the your schedules. So only theory class are there. So in this four season, there is not much of the important theory. So that's why I just take one practical class. But it is not scheduled as one practical class is there. Maybe another practical class will be there for any other faculties there. So I don't know. So the IGNU team will decide practical will be there or not. For me only this is theory class. So it is not the practical. I just extra class. I just give you for the practical.
Oh,
And sir, you are
okay, sir.
based
Thank
in
you so much, sir.
Bhubaneswar. Are you based in Bhubaneswar, sir? If we get a chance, how to meet you?
So I am working in forest department. So in the Jaidevya, and you can contact me in my number or in WhatsApp. You can then discuss any related to this.
So
So,
nice of you, sir. Really
if anyone, so one thing I want to know, give you, so anyone working in like GIS field, or if any problem is there, then you can consult me. If it is possible, then I will try to solve it. Okay, because in after that you may be working in this field, and after that a uh, lot of issues and lot of confusion will be there after working in this field. So, so uh, try, we'll try for the best.
so nice of you, sir. Really appreciate. Thank you very much.
Thank you.
Thank you,
Yes,
sir.
sir. Thank you so much, sir.
Thank
Thank
you.
you.
Thank you, sir.
Thank you. Thank you.
Kanay, our thanks to our Rakesh Pranjit Thakurji also, sir. Because
Okay.
today is the last class, no?
Yes. Yes. Okay. Okay.
Thank
Thank you.
you, sir. Thank you.
Thank you.
Thank you, sir.